energy and power basics. Before we proceed dun sa mga uh, energy estimation of renewable energy sources. Nagre-record na ba? Ano?
Yes, sir.
Baka si
Okay,
Jasper, sir,
sige.
ang nag-next.
Okay, sige. So last time, I already gave you your first activity, no? With regard to biomass energy estimation. So that's actually a part or related to your group project. No? Actually, yung discussion natin is also related to that. But the paper that I gave you deals more on actually two topics in discussed doon. One is for the statistical estimation and the other one is for GIS, you know, Geographic Information System, which is parang a booming area of study for estimating energy. In fact, DOE is aggressive with regard to the mapping, no, of renewable energy uh, sources, no, potential in the Philippines kasi there are companies that are trying to establish businesses in the renewable energy sector. No, kaya they're trying to centralize that and hopefully come up with an online system, you know, where you can see yung energy renewable energy mapping all across the Philippines, no. Like they already started gathering data. Actually umupo ako sa isang panel, no. So DOE is actually outsourcing yung ganong klaseng system ng mapping to, of course, interested proponents, no, mga researchers from different universities. Yun nga, to come up with an integrated, no, renewable energy ang tawag dito, interface, no. So I think online siya, both online. I'm not sure if there's an app included, pero ina-outsource yun ni DOE kasi wala silang expertise pagdating sa parang mapping, you know, tsaka interactive kasi yung mangyayari. So this is to aid yung mga companies that would like to put up business, no, in the renewable energy sector. And it's, I think, part of the EVOS. Mamaya later siguro I'll show you that project. Okay, so we start, no, energy fundamentals introduction. We covered already the topics, no. So today I'll be discussing this in introduction, energy, no, renewable, non-renewable energy sources, energy and power basics actually. And then we'll see if I can continue the lecture on biomass. If not, then I'll start discussing that next meeting. At least simulan nyo na rin. Okay? Wala pa rin tayong Chinese dito. Anyway. Okay, we have a book we can read about fundamentals of renewable energy processes. I'll just send the link later if I've not given the link yet. Just for reference, but it's not a required textbook. Kasi mostly lecture naman tayo and from papers. So again, the focus is not on non-renewable but on renewable energy sources like biomass, solar, wind, hydro, wave, and other forms of renewable energy. Okay. Ayan, I've discussed the requirements, so I hope it's clear, no, for everyone. To those who are under HP 513, I hope it's also clear. Ano ba ditong nasa HP 513? So you have different set of activities. Take note of that. Don't mix them up. Okay. Uh, Clear naman siguro, no? If you have questions, clarifications, just let me know so you won't, confuse. You will not be confused with the activities, no? You have different set of activities. Okay, so make sure you're doing the correct assigned activity for for your group or for the individual activities. Okay, so these are the topics for HP 513. So combustion ng solid liquid and gaseous fluids. Okay, requirements again also for 5 HP 513. So just let me know if it's not clear. Okay. I also of course send this presentation to you, no, for reference. Kasi ano na ba tayo? We are on the fifth week, right? Fifth week or sixth week? Or parang fifth week pa lang, no? So, ayan. Uh, Hopefully, ma-finalize yun yung mga topics and yung mga papers so you can start early. Okay. So this is, I have a report, no, individual reports for HP 500. Okay, so now we continue with the lecture. Again, this is just a review. Most of the terms or topics here are quite common, no, for us engineers. For a recap or recall of some energy and power terminologies. So again, in definition, energy is the capacity to do work. Okay, we have some formula that we use to determine work. Yeah? Work is force times distance, so that means the object should move. No? If it doesn't move, there's no work, no, applied. Okay, in an electrical system, that means the charged particles, no, uh, are moving by use of the electric field. Okay, we also should take note that work and energy are not the same thing. You can apply energy, but there's no work, no, done. So you can, yeah, expend energy by pushing the door, but if it doesn't move, then there's no work done. So again, it should be, yeah, force times distance. Okay, there are different this is, I think, forms. Maybe should say types of energy, both renewable and non-renewable. It's just a summary. Also, we have the heat energy, radiant energy, light energy. So in engineering and science, we can actually quantify them, no, using equation. Diba? For heat, no, for radiant energy, even for radiant energy, yan, we're using Planck's constant, light as well, no, chemical energy, yan, mechanical, gravitation or yung potential energy, electrical as well as nuclear. So you can break them down, of course, to renewable and non-renewable. Ayan. So these are some of the examples. Radiation, solar, and what else? Yung radioactive, no? Uranium, plutonium. Just recently, actually yesterday, no, we visited PNRI, no, Philippine Nuclear Research Institute. They're becoming aggressive na sa training ng mga personnel or staff for renewable for nuclear energy. Okay, they wanted to nuclearize people. So when you say nuclearize yung mga tao, like for example, if you're a chemical engineer or a mechanical engineer or civil engineer, you have to undergo nuclear engineering training, no? So you could work in a nuclear energy power plant. So the training will take maybe about a year para ma-nuclearize daw yung isang personnel, no? Um, so far yun, they're still uh, training people in preparation for the nuclearization of Philippines. They're planning to establish yung mga scale of not as big as the Bataan nuclear power plant, but the modular type. If you have heard of that, yung modular type, that's the size of what they use in aircraft carriers, no, yung mga nuclear powered aircraft carriers, tsaka yung mga submarine, yung nuclear powered submarine. So ganong size lang. So, and then you can scale it up, of course, by adding up more modules. It's easy daw to commission compared to a really big power plant, no, nuclear power plant.
Sir, may tanong ako, sir.
But
Sir,
as of
Sir Carlo,
sige.
meron
Sure,
po
sure,
bang
sure.
meron po bang ano, parang may nabasa ako na parang gustong ituloy ng Marcos government yung tungkol sa ano, sa nuclear. Meron po bang gano'n?
Ay, sa
Ano?
BNPP, yung sa Bataan.
Opo, meron po bang parang rehabilitate
I
or yung Meralco
there
ang
are
ano?
talks. There are
Okay.
talks pero kasi it will be very expensive eh. Costly yung rehab, I think eh. Yun yung nabalitaan ko doon. Kaya si PNRI is sticking to the original, which is
Ah,
yung sa modular.
modular na lang po. Okay. Yung parang yung mga small
Modular.
applications po.
Malaki pa rin naman ang mapapower nun kasi kung for example yung sa yung aircraft carrier, 'di ba? Yung aircraft carrier malaki yun eh. So
Mm.
community rin ang kayang i-power nun.
Oo.
Oo,
Parang planta rin po, parang
malaki rin.
planta rin.
Planta rin talaga siya na pero not as big as yung parang will cover the whole region siguro.
Mm.
Baka
Gano'n din yung ano, sir, 'di ba
isang
meron ding
town.
mga nuclear powered submarine yung US, 'di ba, tsaka Russia, gano'n.
Yes.
Parang gano'n
Yes,
din.
ganun yung correct, correct. Ganun
Ah,
yung gusto natin. Kasi madali daw i-ano yun, i-commission, madaling i-construct. Tsaka konti ang personnel sa
okey po. Thank you po, sir.
pagme-maintain. Ganun pa rin yung trend eh. Although hindi namin nakausap si Director Caloy, no? But yeah, some of the officials in PNRI, yun yung trend. Okay, and then if you have heard of that, they had the first Olympic nuclear Olympics. We won first place sa individual, but uh, the group category, the champion was from Singapore. We hosted that, no, with of course with support from the ano yun, Atomic Agency, the National Atomic Agency. So yun, that's the trend. But as of now, we use nuclear for irradiation ng food for export, no? So yun yung ating application for nuclear energy for food processing, yan, sterilization for export, no? And then we also have one study about what you call yung naturally occurring radioactive materials norm. Kasi diba, if you will notice, there are some places where uh, uh, incidence of cancer is high. And they're saying na there are natural materials that are also naturally radioactive. Yan. So, yun yung inaaral sa atin ngayon. For example, sa amin, sa in the Taguig campus, our librarians, two of our librarians died of a cancer. So yung incidence, it's I don't know if it's just coincidence, but the frequency is a little bit high. So there's a study going on to analyze the bricks kasi the UP campus was established way back 1977. So we don't know the characteristics of the building materials used in there. So now they're sampling bricks to check if they have norms, no, yung naturally occurring radioactive materials. What else? There are so many in the Philippines, all over the Philippines, we have a lot of hot springs, and they say that hot springs have high radioactivity. And so and the owners, no, yung mga resort owners, they're not aware of that. And there's no policy of like limiting tourists, no, or people in the use of those hot springs. Ang sabi kasi if the radioactivity, I think it's microsieverts something. If you exceed this, I mean, if there's a radioactivity level of that, value, you should more or less spend uh, your time there for a maximum of 1 hour. You cannot exceed 1 hour. Otherwise, it will be unsafe, no, for the user. So may mga ganong situation or locations in the Philippines na ano mga hot springs. But we don't have a policy for that yet. So yun yung inaaral ngayon. They're trying to relate the norm yung naturally occurring radioactive materials to uh, yung mga hot springs or yung mga areas where people are visiting to keep them safe, of course. Ayan. So far that's the level of the nuclear application here in the Philippines. That we do not we're not going yet to nuclear energy. In hospitals, of course, we use radiation for the scans. No? Okay, so for chemical, ayan, we have, of course, the solid, liquid, gas forms. Yan. For biomass, we have the wood. For oil, we have petroleum. They contain energy. In chemistry, they're what you call hydrocarbon. No? So it's composed of hydrogen and carbon, which both elements can burn, no, in the presence of oxygen. So obviously, if you burn carbon, it becomes CO2. If you burn hydrogen, it becomes water. Okay. In batteries as well, yan, mga hydrogen fuel cells, those are all chemical in nature. Potential, and so we have the dams, no, that converts potential to kinetic. So potential is related to the height, no, and if there's a change in the height, no, it can be translated to kinetic energy. So you can harvest that potential and kinetic go in hand in hand. Another example of kinetic ay yung sa wind and water. Of course, movement of wind and movement of water. Okay. Okay, what else? Thermal or heat. Obviously, we can we call it parang sort of harvest, no, heat from combustion, which we can use for other applications. Through, of course, heat exchange. And even, syempre, sa power generation, the heat is used to power up steam turbines, right? We use that. The fuel can either be renewable or non-renewable. But it's usually, for example, in coal power plants, yeah, obviously it's not renewable. But we use the co-firing technology to reduce the amount of non-renewable fuels that we use. Same with liquid fuels, no? For example, in vehicles, 'di ba? Yan for gasoline, we add ethanol, no? Bioethanol. For diesel, we add biodiesel. Ayan, on Monday, kailan ba? Tama ba? No, on Tuesday pala, I will also go to a DOE forum kasi they're trying to increase the biodiesel blend in liquid fuels, no, in biodiesel, in our commercial diesel. So currently it's at B2, 2%. The initial target was B5 dapat eh, no? So from 2%, it will increase more than double, 5%, but I think it's na I don't know, maybe the price will increase a lot, or maybe the production capacity is not enough. So ngayon ata they're just trying to increase it by 1% lang muna. So we will transition na from B2 to B3. But originally it was B2 to B5, no? So ayun, no? Thermal energy, yeah. We can get heat from this. Sa gaseous, meron din, obviously, natural gas. It's non-renewable, but biogas is renewable. Okay, so we use that heat for cooking and for other applications, food processing, obviously. No, aside from energy generation, no, ilang energy, no, we can use heat for other applications. What else? Yan, mechanical energy, example, yan, moving shaft, no, yung sa sinaunang milling processes, right? Yung mga windmills for milling corn, no, or wheat. Yan, so mechanical power using water and wind to drive the mills. Okay. What else? Ayan, electrical energy, of course. An example ay batteries. Okay, right now, ano ba yung mga battery na? Yan, yun nga, I think I mentioned this in one of the lectures. Philippines is going towards sodium batteries. So if you will see yung at our rechargeable batteries, no, in our mobile phones and laptops, computers, most of them are lithium based, right? Lithium based batteries, lithium polymer, etc. It's lithium based. Even for EVs, electric vehicles. By the way, isa pa palang update. No, DOE will also donate an EV trainer in TUP Taguig. So for those who would like to explore or to venture research on electric vehicles, you can collaborate with faculty members in TUP Taguig for EV research, no, electric vehicle research. Pero ano lang, we're just starting up. No? We will have an EV charging station and trainer. Um, we're still looking for EV experts kasi wala pa. But there's a budget. So there's a budget for EV training and hopefully EV research.
Bale sir kayo po
Okay.
sir excuse, kayo po yung magpapa-train bale
Ah,
sa TUP Taguig?
yes, TUP Taguig ang
Pero wala pang mga ano
magpe-prepare
yung
ng training materials.
hindi pa po naka-roll out yung mga topic like kung sa battery gano'n, sa control or
Wala pa. They're
wala
still
pa?
looking for speakers, experts.
Okey.
Oo.
Ano yun sir
Ah,
bale funding ba
ang
yun? Funded po o
yeah,
bale
it's a 2 million funded project by DOE. Kasi
ng
we have
Department of
been Department of Engineering. We have been a recipient for several years na. The first one was I think yung natural gas vehicle, tapos
LNG po,
um
gano'n, LNG.
tapos yan, LNG. Tapos naging LPG. Yan, we've been a recipient for LPG training. Tapos ngayon naman EV.
EV
Oh,
po.
but we're still EV naman. We're still starting, and then yun nga, we're looking for experts who will be conducting training. First to our faculty members muna kasi yung mga magtuturo.
Saang
Kailangan
department
sila
po
yung
sir naka-ano, Sir Ferret? Saan pong department siya naka-under?
Sa
Sa
automotive
sa automotive po? Okey.
automotive. Still under mechanical engineering. Kasi the design of our departments is allied. So for example, mechanical engineering, under mechanical engineering, you have several programs. Yan, automotive, HVAC, no, non-destructive test, mga ganun. So it's still under mechanical engineering, under the automotive technology program.
Okey po.
Okay. Ang the funny thing is, yun nga, there's a very limited, experts 'no, on EV here in the Philippines. But buti na lang, I have, yung aking, nephew may ano, EV trained, eh. So, baka ma-invite siya ano, to a speakership when the seminar will push through soon. Kasi ano siya, eh, EV trained sa Germany ng Porsche. Ang problema, medyo mahina yung management ng Porsche sa Philippines. Ah, ano siya, ah, napunta sa Don Bosco tapos umalis na rin eventually dahil nga due to poor management. He transferred to GD and now he's in MG. Kasi yung mga Chinese company ngayon talaga, they're number one in terms of EV sales, no, EV production.
Mm.
But of course, they still, wala pa rin ano sa European tech. But yun nga, very aggressive ang ano,
Mhm.
Chinese EV
Pinasok na
companies.
tayo ng ano sir, ng EV ng Chinese, eh, BYD, MG,
Yeah, yeah, oo lahat.
yan
Magaganda
nandiyan na
yun.
sila. Oh,
Even MG, although MG is British brand, di ba?
pero binili yata nila,
At,
parang may bumili sila ng
yeah,
license.
yeah, ano, hindi lang license, I think talagang ano,
Okay,
shares talaga, majority
share nila,
shares of uh,
MG,
of ano, o MG ay owned na talaga ng
China.
China. I think hindi ko alam kung SAIC ang may-ari or something. Sa Chinese company pa rin. So
Mm.
yun yung ano, halos lahat na pati even Volkswagen yung mga malaki na rin ang ano, ang ownership ng Chinese company doon. So talagang ano, they're catching up no, with European ano, European brands, European companies. Kasi European din yung binibili nilang mga design and patent, eh. Ayan, yung material na lang siguro magkakatalo 'no, yung quality at baka hindi gano'n kasing tibay. But and the parts, yun yung mga usual na problem natin. But for yung Japanese kasi talagang ewan ko paano nila ginagawa yan, but parts availability is always there. But for European and Chinese, mahirap. Okay, so ayan. As mentioned, we can classify them into renewable and non-renewable. For again, the focus of fundamental energy fundamentals is on renewable energy. You'll be doing energy estimation of potential energy, renewable energy sources in the region. No, I've seen that there are already pairs or groups posting their selected region. No, so again, ang mandatory estimation is the biomass. No, biomass energy. If you can see on the left side, no, there's biomass energy, and then plus maybe plus one or two renewable energy forms. No, it depends on the region that you have selected. No, so you can maybe choose solar, no, and wind together with the biomass or hydro or geothermal. It's up to you. But take note, this is not existing, but the potential. Parang augmenting the existing. So do not select areas in the region where there are already existing renewable energy power plants, no? Renewable energy producing companies. So you select regions or area which you consider to be a potential, possible potential renewable energy source. So i-estimate nyo lang naman. No? So, unfortunately, wala pa yung sa DOE. It's still, yun nga, being, ano ba to? Under consultancy pa, no? I'm not sure if UP has already won the proposal. It's actually a 35 million project, eh. So, in-outsource nila. No? DOE outsourced that project to Pisherd. And then Pisherd is looking for, yung proposals from different universities, university researchers. Okay, and when I attended When I paneled the presentation, only two universities submitted. One from UP and the other one from Perpetual in Las Piñas, I think. But ayun, siyempre medyo mas malalim na yung pinropose ni UP. But I'm not sure if they won that proposal. Kasi doon you can really see the sort of yung ginagawa ni uh, NREL no ng US National Renewable Energy Lab, NREL, and USGS, no, US Geological Survey. They're doing that as well, no. But this one will be interactive and it will help guide companies that would like to venture on renewable energy. Okay, so these are renewable. Of course, we already know the non-renewable energy sources. Yan. Petroleum for the liquid source, coal for the solid, okay, natural gas for the gas, okay, and then nuclear energy. It's also non-renewable, but cheap source. Okay, we're transitioning to that as well. Okay. Again, there are renewable counterparts for these non-renewable energy sources. No? For example, coal, biomass ang counterpart niyan. No? Agri-waste, biomass, etc. Or can even be municipal solid waste. No? If we have incineration, no, incinerator power plants in the Philippines. Fossil fuel oil, of course, we have the biodiesel, bioethanol, ayan, yung mga liquid fuels natin, and then natural gas, we have biogas. We also have the renewable counterpart for this non-renewable energy. But again, the technology is very much established for these fossil fuels, no? That's why the transition is very, very slow. Okay, so how much power is generated? Back to basics, power is equal to ayan, volt times VA, no? Volts times ampere. A power unit is watt, no? Watts. Voltage, that's joules per coulomb, and ampere is coulomb per second, right? Okay, so 1 volt is 1 joule per coulomb. Current is, or ampere is 1 coulomb per second. So if you multiply, you get joule per second or watts. Now, a coulomb is equivalent to about 6.24 times 10 to the 18 electrons. Review lang yan. Okay? So, power is also work over time. Okay, so power is also work over time. For example, ayan, I have a 10% efficient bulb with a rating of 0.4 watts and you run it for 15 seconds. The question is how many energy in joules is needed. Again, work. What's the unit for work? Do you still remember? Ang unit na ginagamit natin for work. Other than joule, of course. You still remember? Back to basics.
Yung Newton meter po ba, sir?
Yeah, correct. No, it's Newton meter. Kasi well, work should have a distance covered. Newton meter. Yeah. Uh, force times distance. Yeah. Or joules. Okay, so how we can compute for this? We already have the formula, no? So 0.4 watts equal to, you're asked to find the energy, no? In joules. Find the work, no? So we have 0.4 watts equal to the energy, the work over 15 seconds. So take note, this is only at 10% efficiency. So that means you need more work, you know, because if it's only 10%, sorry, you need more work because you are only working at 10% efficiency. The rest, I don't know, maybe lost in the form of heat. No? So only get 10% light, 90% heat, something like that. No? So, sige nga, ano yung computation natin dyan? Basic energy calculation. How much, ano kaya yan? How much energy is needed to power this inefficient bulb? No? And incandescent bulb lang siguro to. What did you get? What value did you get? You can use your phone or something, calculator. At anong complete mo? Ilang
60 joules po
ilang,
dapat, sir.
how much?
60 joules po.
60 joules. At 10% efficient. And so here, you can see yung watts, yung powers multiplied by time, then you divide it by the efficiency. 0.1. So only at 10%. You need, 60 joules. If it's 100% efficient, this is much less, right? So you only need 6 joules. So yung bill mo sa kuryente, it's much less. No? So it's really important to buy efficient appliances at home. Yan, like aircon, refrigerator, TV, because you consume less power. Okay, now what if the um, bulb is rated at 100 milliamperes? How much DC voltage is needed? Take note, power is also no volt times ampere, right? So VA. But again, at 10% efficiency, how much DC voltage is needed to power this 100 milliampere uh, bulb, no? At 10% efficiency. Ang computation nyo dyan. Yun po. We have our Chinese. Oh, still not here. I don't know. Still not around. How much did you get? So it's like, 0.4 divided by 100 milliampere. So that's how many amperes. Tapos, at, of course, 10% efficiency. How much voltage do you need to run that? Anong computation natin?
40 40
40 volts, no? Tama. Ayan, 40 volts, no? 10% efficiency. 4 volts lang sana kung efficient, no? 100% efficient. But you need more. 40 volts. It's a huge increase because the bulb is not efficient. Okay. Pero baka kailangan mo yung heat kaysa sa yung light. Kaya siya inefficient. But anyway, again, it's beneficial if you have a very efficient system, no? So you would consume less power. Okay, so energy is an important commodity in modern world and used in so many applications areas, no? Electronics, automotive, yan, uh, even pharmaceutical, medicine, agriculture, no? Okay, so a lot of things, a lot of industries need energy and communication as well. Okay. Unfortunately, we are still dependent on fossil fuels. If you can see in this projection, actually, hindi na nga projection to. This is very old data, 2006. Pero pinroject niya kasi to 2000. Okay, and it didn't even change. Up to now, the trend doesn't change that much. No, we are still dependent on fossil fuels. If you will check in this graph, when we started industrializing, no, in the 1800s, and dati wood lang gamit natin, no, for light and heat. So when we discovered petroleum and coal in the 1800s, yung industrialization, ayan, the use of fossil fuels has increased almost exponentially, no? In just a short period of time, 100 years, we are already experiencing drastic changes in the climate conditions, right? So yung mga dating normal precipitation, no, normal rain feels like typhoon way back, no, in the 90s. Ngayon yung ulan ngayon, lalakas, no? Parang bagyo, but it's just a typical rain, no, now. And if you will check here in the graph, it's probably because of the use of fossil fuels. Although there are so many, people also dispute that, no, yung increase in global GHG, no, greenhouse gases. They dispute their relationship to global warming, no, but of course, numbers don't lie, no, data. And we have data to support that, no, yung increase ng GHG to global rise in temperature. Ayan, but meron kasing may mga they don't try to analyze the data. Okay, but again, the trend is the same. If you will get the projection of recent studies on the use of or on the sources of energy, still big part of our energy needs or demand is supplied by fossil fuels. So dito coal, petroleum, and natural gas. And the hydroelectric is low. Ano yung isa dito? What's the wood? No? Biomass pala. Okay. Biomass and water is small, no? And maybe the other renewable energy sources are quite negligible, no? Like solar and wind. Okay, nuclear power, there some of the countries now has already have already phased out the nuclear energy sources. I think in France, di ba, parang nag-decommission na sila ng mga nuclear power plants. Okay, so this is a more recent data. This is 2006. This one is 2013, British Petroleum. Ayan. Still number one is petroleum, oil, followed by coal, and then natural gas. Top three, fossil fuels. Fortunately, that's still the trend, no? But, ayan, due to the advancement of technologies, improvement in the design, the renewable forms are also increasing, trying to catch up with these fossil fuels and hydro and other renewables, solar, wind. Okay, another data projection by 2040. Unfortunately, there are still the top 3 energy sources, no? Unfortunately, fossil fuels pa rin. Kaya, I don't know, yung mga protocol, no? Yung sa Paris Convention, no? Kyoto Protocol, I don't know if it they did well in the agreement. But yun nga, it's still hard to beat the technology, no, established technology of fossil fuel. Ayan. So, nuclear, ayan, tayo, papunta rin tayo doon, that direction. Okay, what else? Projection, as I've said, yun nga, there's no slowing down. There is slowing down, but I mean, there's still the top 3 energy sources natin, even the Philippines. Despite fact that we are an agricultural country, you know, should be aggressively pushing for biomass energy, right? But yun nga, kulang tayo sa engineer, scientist to develop yung mga ganong klaseng low cost tech that will utilize biomass. Okay, energy flow. So we have energy flow, and each layers or stages uh, has to be efficient for us to really recover yung energy from the source. Okay, so we have primary energy, okay, which is available in the natural environment. So that's our primary source. Secondary, which is energy for ready for transport or transmission. So if it's in forms like liquid, solid, or gas, you have to transport. For transmission, that means electricity na yan. And then we have final energy, which is consumed by consumers, no, or bought by consumers, or the energy that we receive at home or in commercial buildings in the industries. Okay, and then finally, useful energy. It's what we get when we apply energy yun sa mga appliances natin and other machineries. Okay, so in each conversion step, there is energy loss. So we want to have technologies that are as efficient as possible. Okay, so ito yung mga examples. From primary to secondary, we have some conversion technologies. For example, yung coal, ayan, wood, coal, ang conversion ni coal may power plant, no? In order to use coal to fire up yung mga boilers natin and steam turbines to produce electricity, no? Pag ano naman, for example, wood, yan, for wood, ang conversion natin, you can use a digester, yung mga anaerobic digesters, no, AD, to ferment wood or to decompose wood and produce biogas. And so, ayan yung, nakita nyo ba yung table? Can you see the table? Right?
Yes, sir.
Okay, yeah.
Yes, sir.
So, may mga conversion technologies tayo dyan. Yung appropriate technology. What else? Hydro. Same thing. You need a power plant, yung dams, no, to convert it to electricity. So, from potential to kinetic. No? Dung, same. Dung naman, dumi, yung manure, no? You can use digester to produce biogas. Oil, you use a kiln or a refinery rather. Oil, petroleum, crude oil, you use a refinery to produce gasoline, jet fuel, diesel, no, kerosene, naphtha, etc., LPG. So there are what you call conversion technologies. yung kiln is for heating eh. You can use wood. You can use kiln to convert wood to oil or heat. Kami, for example, in TUP, in Taguig Campus, I've been advising researches on pyrolysis, no? Pyrolysis of biomass. I have groups in there converting used tires, for example, or waste biomass, no, like ano ba yung mga nahawakan namin before? Coconut, let's say coconut biomass, convert them to oil, no, pyrolysis oil through, of course, pyrolysis process. Okay, so we have successfully converted din naman, but we're still optimizing the process. Our design for the pyrolyzer is not that good. We can produce pyrolysis oil. So I have a few students working on biomass pyrolysis. Okay. Now we're trying to improve the design. So hopefully we can come up with a naturally powered kiln or pyrolyzer. We're also venturing on microwave pyrolysis or microwave assisted. Ayan, I have a group na dyan. Patapos na rin sila. So, microwave pyrolysis. Um, did they use? Forgot. So, agree pa rin, no? Biomass pa rin. Wood pyrolysis via microwave process. Ayan. What else? Yeah, so far yun yung mga conversion technologies. Yeah. Recently we're doing also torrefaction naman kasi it's much easier, no? To do than do pyrolysis kasi the product of pyrolysis ay oil, liquid fuel, but the product of torrefaction is more on solid. So you're just essentially increasing the heating value of biomass, no? By removing moisture, no, or carbonizing the wood. Essentially, you convert wood to charcoal, no? Cooling kasi it's easier to burn, no? It's of course more efficient and it's renewable. So we're I have a group working on that as well, no? Torrefaction of wood. Plus you can also apply torrefied biomass to agriculture. No? Yan yung mga ginagawa namin ngayon in TUP. Next, yung from secondary to final. Ayan. So the forms ng secondary energy are the following yan: refined oil, electricity, biogas. So for example, refined oil, since these are examples are yun nga, diesel, no, gasoline, kerosene, jet fuel. So you can transport them, no, through trucks, no, and pipes, obviously. Yeah, that's why you see ano, 'di ba, yung mga trucks from let's say Batangas port. Before there is a refinery in Batangas, right? There's Caltex and Chevron and Shell, no? In anong lugar ba yun sa Batangas? Namutang kasi taga Batangas dito. There used to be a refinery, Shell refinery there, and Caltex or Chevron refinery. Do you still remember which part of Batangas? Anyone familiar? I forgot. Uh, Malangaw ba yun? Get those there. Tabangao, right? Sino taga Batangas dito? I think it's Shell Tabangao or Tabangao, Batangas, no? So we have a refinery there. And there's a pipeline from there going to also before there was a depot, no, in Pandacan, if you will remember, no? 'Di ba yung naging issue pa yung Pandacan depot na yan. So they have the Batangas-Manila Pipeline, Batman, sinasabi nila. Pumping oil, refined oil from Batangas Refinery to Pandacan, no? Shell Pandacan, yung depot doon. Ngayon wala na. So there's been provision. The refinery, Shell refinery, the nearest I think is in Malaysia or Singapore na. So what we have left is the local, yan, Petron. So we have the Bataan Refinery. So they are transported through trucks, obviously, because that's much further. Or I don't know, maybe through pipeline. I've heard, no? So maybe through pipeline, underwater pipeline sa Manila Bay from Bataan. I'm not sure. But yun. So trucks definitely transport the refined oil from Bataan to Metro Manila. Talking about Metro Manila. Okay, for electricity, of course, it's wires, through wires. So yung power plants, no, from Batangas, from Laguna, we have power plant. We have natural gas power plant, di ba? And coal, obviously. The power is transported through wires. Electricity is transported through wires. And then final, ayan, so from trucks, ayan, trucks will contain different types of fuel, no? So there's titimplahin pa yan. They will put additives and other things, no? Improve the properties of the refined oil. And then you can sell them in the form of diesel, gasoline, kerosene, jet fuel, etc. Okay, so that's your final. What else? Charcoal. Charcoal. Final, if you convert yun nga, wood to charcoal. So you can use that at home, no? Co-firing as well for boilers. Final also is electricity. That's what we receive at home. Then biogas. Okay, you can also use that for cooking, syempre. Especially dun sa mga rural areas, no? Even the UST, they have their designs of biogas digesters that can be installed in rural areas. You can use manure feedstock or biomass feedstock to produce biogas. So you can use that for heating, no, or cooking. What else? Even in industries, no, such as let's say yung Dole pineapple plantation, they have I think commissioned a biogas plant, and big poultry companies or industries, they're also using biogas plant. What else? In Metro Manila, yung mga food companies like San Miguel, I believe they also have biogas digesters. No? So they use that for heating yung mga food processing or food processes. No? And yung final conversion, of course, conversion technologies, you have motors, heaters, stoves, okay, and then useful energy, heat, and power, no, electrical or mechanical forms, no. So these are what we call energy flow, and each of the conversion technologies has efficiency. So the objective, of course, is to ensure that the conversion technologies are as efficient as possible. Okay. So ito, another illustration of the conversion of energy. So, example, to, what is this? Mali, no, nasa farm field eh. But this is a petroleum rig, no? So, land-based petroleum rig, no? They collect petroleum in Texas and in um, ito, Ohio. So, may yung, tama, Ohio. Yun yung Cleveland, right? Ayan. So, in Ohio, in Texas, ayan, they have so much oil deposit land. In Utah, I think also. So they pump oil underground and then transfer that to refineries. So there's conversion, and then the refined oil are stored in depots and transported by trucks. And then of course, you use that, yung diesel and gasoline in our vehicles. No? Dito yumaman sila Rockefeller, no? Yung mga US tycoons, business tycoons, yan sila JP Morgan, sino pa ba yung mga mayayaman? Rockefeller, Cornell, yan. Kasi pagyaman yan because of the discovery of petroleum and coal, no? And syempre, yung mga finance, mga pautang, yan, railways, yan, ano din, has prospered because of discovery of fossil fuels. Okay, what else? Sa mining, meron din. Coal, for example, yan, yung coal, collect coal, use that for power plants, ayan, to produce electricity and transport it through wires. And then it can use them at home or in different industries. Okay, so each steps has their conversion efficiency. Okay, for this one, there's no storage. Unlike this, there's storage, because you have to distribute those refined oil. This one go directly, unless you have a battery facility at home in case of brownout, but that's not practical. Obviously, battery system is very, very expensive. That's what makes actually the solar plant, or solar setup, solar system setup at home expensive, very expensive because of the battery system. Okay? So again, components of an energy system include yung collection, conversion, storage, and transport. Okay, so as engineers, we find systems that are as efficient as possible. We develop technology with the greatest end usage. In the Philippines, unfortunately, we rely on efficient technologies abroad. No, but it's hard for us to adapt because uh, most of them are quite expensive. No, so the challenge for us researchers, engineers, is to develop our own local technology, which is affordable and efficient. Dami-dami nating engineers sa Pilipinas, but sad to say, we are still relying on foreign technology. So, yun nga. Iba yung parang focus kasi ng ating R&D. Ngayon, since we're sending so many scientists or researchers, PhDs abroad, and they're coming back, we have the Balik Scientist program, and we're trying to catch up na. So before there's a brain drain, right? Kasi sobrang hirap ng Pilipinas eh. So our experts or scientists, they go abroad to find greener pastures. They don't come back anymore. Now, we're investing. So we have the Balik Scientist program so that these engineers, scientists who studied and even working abroad are enticed, invited to go back in the Philippines and share their expertise so we can develop more experts locally. Yeah. So maganda yung program ng DOST, mga ganun, Balik Scientist programs. And they have so many benefits. Nakakaano talaga. Entice talaga for those who are already living abroad, for them to come back here in the Philippines. May example lang yan, yung although wala pang Balik Scientist before, si Justado Banatao, he's just really a philanthropist. He came back to the Philippines because he's already a billionaire. I think, billionaire na yun si Sir Banatao, no? So he started this scholarship program, no? Yung Engineering Research and Development for ERDT, Engineering Research and Development for Technology. And sad to say though, TUP is not part of that consortium. Hindi pa siguro gano'n ka-solid yung engineering ng TUP. Pero ang members yan, most of them are private, no? So, sino ang nandiyan? I think Ateneo, Lasal, UST, part of the consortium, Mapua. I'm not sure about TIP or Adamson, but those are private schools. UP lang ang kasali at saka MSU.
MSU yata, sir. MSU po, tsaka San Carlos.
Sa kasali na rin San Carlos is also private, right?
San Carlos. Tsaka yung sa Dumaguete, sir, yung Siliman.
Iliman, those are all I think private schools
Private
pa
po
rin,
na,
no?
ano,
So ang
religious, opo.
ang government lang talaga, ang public school lang is MSU. Ibang level
MSU
din
tsaka
naman kasi ang
UP po.
MSU. UP, yes. So far yun lang silang dalawa ang public. Di nakasali ang TUP. Although I think meron tayong isang scholar in the doctoral program. He is a DUST SEI scholar. He was allowed to study in TUP, the doctoral program, under DUST scholarship. For undergraduate, yes, we have DUST scholars in the undergraduate program, but in the graduate program, wala. In the engineering, yeah. Or maybe in other SEIs, UST scholarships, no? But yun nga, there's one I know who was allowed to study in TUP, the doctoral program, and at the same time, a scholar of the UST. So yun yung mga challenges. Hopefully, pag tumaas ang ranking ni TUP, masali tayo sa consortium. Okay, so that's the challenge for us, engineers, scientists, to come up with our own technology that is efficient and low cost, no? Compared to foreign tech. Yeah. So this is the energy profile, no, of the Philippines way back 2014. Ayan, more than 50% is still we are still dependent on fossil fuels, no, or non-renewable fuels. Coal 29, oil 23, natural gas 14. That's almost 60% pa. Lagpas no? More than 60%. Tama. 20, 30. Tama ba? 29 plus 50, ano ba lang yan? Lagpas 60 yan. So more than 60% is sourced from fossil fuels, unfortunately, in 2014. I think this didn't change that much, no? Current status of our energy mix. So ito yung ating energy mix.
Sir, Ferrer,
Tapos
question po.
yeah.
Yung natural gas po ba, ano din? Fossil fuel din po ba yun?
Yes,
Sa
unfortunately,
ilalim din ng
yes, but
lupa
it's
yung galing, di ba? Sa ilalim.
correct. Oo.
So mga
But it's
70.
efficient.
Mm.
Mga
So ang lumalabas,
Mga
sir,
ano?
na fossil fuel po dyan, bali natural gas, waste heat. Di ba yung waste heat halos? O ano to, parang more on
ano
mga
lang,
basura to, mga
yung
basura.
waste heat could be from the generators sa mga
Generators.
so pwedeng renewable, non-renewable sa mga boilers.
Sa mga
So pwedeng
boilers.
renewable, non-renewable 'yan. Ang sure lang would be coal, oil, and
Coal,
natural
oil, and
gas.
natural
Kasi
gas. Okay.
ito yung yung mga raw forms So yun. Natural gas we want to use natural gas because it's efficient, no, combustion efficient, di ba? Shorter chain, so easy to combust. Yun yung reason kung bakit we want to transition to, not actually transition, we want to use natural gas. Okay? Unfortunately, it's contested right now yung exploration of natural gas in the West Philippine Sea, di ba? So, Malampaya is the maybe most popular natural gas offshore platform, but it's about to be used up na. I'm not sure if by this decade, no, 2030 or next decade, maubos na yung Malampaya.
Saan po banda sir yung
Eh,
Malampaya? Saan po banda yun?
Palawan ito
Ah,
eh,
Palawan.
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 Sa West
West
Philippine Sea,
West
yes.
Philippines. West Philippines.
Kaya binabakuran yan ng China
China.
because
Sa
there's so
resources.
much resources there, yes. And they want to secure their energy. Obviously, when you know when a war breaks up, di ba? They want to ensure that they have a continuous supply of energy. That's why they're putting up so many bases there in West Philippine Sea para to secure the transport of energy, no, from their suppliers from Africa, no, from other parts of the world, no? Kasi yun yung daanan ng ships. Okay, so they want to secure that. Aside from the natural gas exploration, yun, they want to be part of that as well. So that's the challenge. Okay, so yeah, Philippines still dependent on fossil fuels. But we're trying to increase our use of renewables, no? Dito hindi pa nakasulat, geothermal lang. Of course, we've been using hydro and geothermal for so long, no? We want now to increase other renewable sources, no? Solar, wind, yan. So on the right side, yung total generation naman, 2015, 2016. Okay? So again, majority of our power generation comes from coal, no? And about 800 to 900 megawatts. Okay? So followed by natural gas, then hydro. We have a total power generation of about 1.6 gigawatts, no, in the Philippines. Okay, so for renewable energy sources, we have this. In our discussion, I'll be focusing on the four. Ito wind, solar, biomass, and hydro. Okay, kasi currently, geothermal is very much established, but the places where you can put up geothermal power plants is quite limited, no? Hindi na nga nadagdagan eh. Right? So it's still there in Albay, no? Albay area and some parts of Quezon, I think, or Laguna, Macban, no? So we won't be discussing that much, no, in geothermal. For wave and tidal naman, it's not that established yet, especially in the Philippines. So we will be focusing more on itong four renewables on the left side, no, wind, hydro, solar, and biomass for the estimation. We'll be discussing some general formulas on how to estimate. Okay. So here is just comparison of the efficiencies of different uh, generation technology, electric generation technologies. And the most efficient or energy generation technologies, and the most efficient is the hydroelectric large power plant. Kasi imagine, direct na siya eh, from cascading water to the dynamo. No? So direct generation. It's just flow of water going to your generators and dynamos, and then you produce electricity na. It can be as efficient as much as 95% efficient. Next is tidal power. I'm not sure if you have already commercialized tidal power in the Philippines. but we've been doing studies on tidal power, mga remote sensing, GIS. We have been doing that studies. In fact, si Dr. Paringit, nung director of PSHERD, is a master, no, a sensei on this, no, remote sensing ng tidal or wave energy. No? He has multi-million projects on uh, tidal, no, remote sensing researches from DOST. Now he's the director of Fisher, si Dr. Parini. Okay, and he's the advisor of the current campus director ng ng TUP Taguig. Si Doc Rex. Ay, mga matitibay yung mga yan. Okay. But yun nga, unfortunately, in the Philippines, I'm not sure, no, maybe if you're updated, that we haven't still commercialized, or there's no company yet investing in the Philippines in the commercialization of tidal power. No, I have not heard of, but maybe you know. It is also one of the most efficient technology, no? Imagine 90%. It's the same principle with the hydroelectric. Okay, so hydroelectric small, ayan, also very efficient. Next, fuel cells, ano na, drastic change, no? 50% and below na. Yung mga succeeding technologies are more or less around 50, 60 and below. Okay, Stirling engine. What else? Fuel cells, they're less than 50%. Coal power plant, ayan, one of the most efficient in the non-renewable forms. Ayan. That is why we can't go away with coal power plants. If you will notice, there's still so many fired power plants in the Philippines. And they're, I think, putting up new ones too. But it's co-firing, I think, na merong biomass na kasama. Okay, followed by oil-fired power plant. Ito yung sa mga cooperative, no, in the provinces, right? They're using diesel, heavy fuel oil for their electric cooperatives, no? Yung mga small scale. Okay, di ba? Yung electric cooperative in the provinces, you will see they're using generators fired by diesel fuel. So what else? There are also fuel cells that have low efficiency. Yeah. Mga PEMS, phosphoric acid, what else? Gas turbine. Gas turbine, when you say gas turbine, they can be powered by natural gas or biogas. Also, landfill gas, pwede rin, no? For example, in Payatas, if you're familiar with Payatas, so that's a controlled dam site. It's actually not a landfill, but it's just a controlled dam site. But they're able to install a gas turbine set up, no, to which uses collected landfill gas, no. Ano na yung landfill gas? Landfill gas, that's also biogas, no, or natural gas or methane gas produced from decomposing municipal solid waste. Diba? If you see the collection of our municipal solid waste, majority or most of that contains biodegradable materials, no, waste materials, waste food, and other biodegradable stuff, no. That's why when you put them in a landfill, as they decompose, they produce methane, what you call landfill gas. So these gas turbines, they are powered by gaseous fuels. Okay, so around 40 to 50. So what else? Wind turbine, yan. BETS limit. We discussed the wind turbine tech later, no? We have the BETS limit maximum lang of 59 to 60%. But that's not the current technology, no? The current technology is only around 40% or 40 50% efficient. Okay. So we have wind turbine, biomass. Okay, saglit lang may patawag. Wait. Yan, sorry. Type na tayo ngayon. Okay, so saan na tayo? Ayan, internal combustion engine, no? Biomass, internal combustion engine, nasa 40% lang din. Incinerators, municipal waste, if you use municipal waste as your feedstock for power generation. Incinerators have an efficiency of about 30 to 40. Microturbines, these are, well, wind turbines that are a smaller version. They're less efficient, obviously, right? Ayan. So, microturbines, yon smaller version of wind turbines. There's also a lot of parang research areas on development of microturbines. Meron bang gumawa yan? Yeah. Si ano, I think, not sure, no? Maybe if naging teacher yun na si Doc Mag-isa, Dr. Alex Mag-isa from TUP Cavite. I think his master's is on wind energy, no? Microturbines. So yung mga design and testing, yan. Medyo bihira rin yung nagre-research dyan in the Philippines. No? It's also an interesting research area. Solar thermal, yung concentrators, no? It's an old tech, but and unfortunately we haven't commercialized this kind of technology in the Philippines. But in other countries they do. Ito dinidiscuss ko to on I think other energy sources, no, yung solar thermal, mga concentrators, heliostats, ganyan, mga Fresnel, solar trough, those kind of technologies. I usually discuss that in another course, no, yung other energy source. It's less efficient, but they're cheap, no? It's free. Solar energy. I have one student doing this, advising, no, sa masters, is uh, doing research on furnace powered by concentrators. No, so not electric. No? Wait. Ayan. So, solar thermal yon. The idea is to concentrate solar to in power plants. They are used to heat up a receiving fluid, no, or salt. Mini-melt yung salt to become fluid, or any fluid that has a high heating capacity. So that heat will be used to convert water into steam in the heat exchanger, no, in the steam generators. Okay, so of course the steam generators will produce electricity. So that's the principle of the solar thermal. So you collect heat and use that heat to convert water to steam to power your steam turbines. Ayan. Solar PVs, ito naman, difference between thermal and photovoltaic. Well, again, thermal is to collect and concentrate. Photovoltaics to convert light energy, yung visible light, no? Yung maliwanag. So it's not dependent on the heat, but more dependent on the light. the visible light, the light that you can see. So yun yung principle ng PV. We will obviously discuss that later sa succeeding lecture. No? Kaya mababa din siya, no? Since the best commercial PVs are nasa range ng 25 to 30 efficiency, no? There are PVs that are still efficient even under cloudy conditions. Okay. Basta maganda yung light, still have light, you can convert that to electricity. But there are, less expensive PVs that is really poor or very inefficient when you have a cloudy environment, no, cloudy condition. Okay, but yun nga, it's still quite low, around 20 to 30. Yung research PVs can reach up to as much as 50%, but that's still research PVs. No? Under research, kumbaga. Geothermal, it's also less efficient, around 20 to 30%. But again, it's for free. So that's still a good thing. And then the OTEC, no? The ocean thermal energy conversion. Probably this has increased already. There's also a limited study on OTEC, no? Ocean thermal energy. So quite interesting to explore, no? Okay. Mapababa to. I'm planning to finish at 12:30. See. Okay, again, yung mga units, we're familiar with that. Newton, Joule, Watt. We've already discussed that a while ago. 1 horsepower, yan, 745 watts. Now, if you run it for 1 hour, it becomes watt hour, no? Or it can also be expressed as kilowatt hour. Okay, so for example, let's say, okay. So for example, how much batteries do we have, yung mga power banks? Ano yung mga typical rating of power banks? It's in ano no? It's in milliampere hours, right? Tama ba? Can you
Yes
check?
po, sir. Mga 10,000, ganun. 20,000 mAh.
Okay,
Ganun po, sir.
yeah, milliampere hour. No, they're milliampere hour. So 10,000 milliampere hour. Instead of expressing that to watt hour, kasi depends on the device. No? So assuming you have 10,000 milliampere hour, and then you can actually estimate how much your battery will last, no? As long as you know the rating, the current rating of a of your device. So for example, if it runs at 100 milliamperes, no, and you have a power bank of 10,000 milliampere hours, no, so you can compute how many hours it will give your device power, right? You just simply divide, no?
Divide lang.
So kung
Di-divide lang, sir.
10,000, correct. So for example, 10,000 milliampere hours yung power bank mo, tapos may 100 milliamperes ka, ilang oras kaya yun tatakbo? You can easily compute. So same principle with kilowatt hour, as long as you, or watt hour, as long as you know the power requirement,
Rating,
no, of your power rating, is power requirement of your device, you will be able to estimate how much hours, no, how many hours it can provide use to your appliance. Okay. So this is an example. Ayan. At 1/2 amperes, running at 120 volts, your bulb consumes, ayan, 60 watts. This is an example. At 1.25 amps, running at 120 volts, consumes 150 watts. 1/4 amp at 140 volts consumes 60 watts. Again, these are just rating. Another important factor that you should consider is efficiency. Ayun. Para of course, a higher efficiency, less energy or less power consumption. Okay, also horsepower, ayan. You can convert um, watts to BTU per hour as well. No? So according to this, 1 BTU per hour is equivalent to 0.93 watts. Or watt, or 0.90 watt na lang yun, less than 1 ba? So 0.293 watt. Okay? And then we have terawatts. So may mga scale yan, depende sa application. So terawatts, 10 to the 12. So this is unit to discuss power at global level. For example, the world generates 16 terawatts, 10 to the 12. Okay, and then there's a question, what's the difference between thermal and electrical watts? So you can note or designate them, or thermal, it's just uh, like WT, no? Or electrical, it's WE, M for the mega. So what electricity or what thermal, no? So let's say, for example, a nuclear power plant generates 2,000 megawatt thermal, which in turn generates 650 megawatt electric. So you need the heat, of course, to convert water to steam that is used by the steam turbines, no, to generate electricity. So from 2,000 naging 650 because of the conversion, no, efficiency. Okay, so here is an illustration. So we have the fuel source, your let's say for example yung nuclear energy source. Your nuclear reactor will produce heat, and then that heat is converted to part electricity and the rest ay waste heat. But you can actually use waste heat, especially if you're in cold location, no, cold condition, no. So that heat can be used to, yun nga, run yung mga radiator, no, sa mga buildings and houses. In other countries, for example, in Europe, they have this radiator in their apartment. So may mga radiator sa bahay to keep you warm during cold climates, ano. And some they are utilized or distributed underground to keep the road also warm and free from ice.
Mm.
Ayan. Siyempre, heating din for people outside.
Sa mga district heating sir nila yun eh, district heat.
Correct. But they are using natural gas. No?
Oh, gas po ang
So um, most European countries, they use natural gas to heat up. In Europe, meron mga sila ring mga boiler sa ilalim ng mga apartments. And that boiler is run by gas, which
yes
of
sir,
course
mga gas
distributes
ang karamihan po.
that heat dun sa building. So it's common in Europe. In the Philippines, we don't need that. We need aircon. No, we need cold air. Okay. So yun yung challenge natin sa mga engineers in the Philippines, how to develop cheaper cold air, no, at home. Okay, other customary units, calorie equivalent to 4.184 joule. Calorie is normally used for food, no, application. And then what else? Kilowatt hour is equivalent to 3.6 megajoule. 1 kilowatt hour is equivalent to 3.6 megajoules. conversion. You should be familiar with that. Especially when you're doing estimation na, no? You have to be consistent with the units, no? Like, or else it will be hard for you to add up, no? Or sum up the total potential. No? So you have to be consistent with the units, especially when you're using different literature. No? For example, in if you're using English English system, English units, no? Tapos there are references naman using System International or American units. Should be able to convert, no, those units to the other. So you could summarize, no, or sum up those computations. Okay. One British thermal unit is equivalent to 1,055 joules. MBTU. Yan. MP, I forgot one. Million or metric, no, not metric. Million BTU or 1,000. So 1 mega BTU is not 1 million BTU, but 1,000 BTU. Okay. The 1 million BTU is MMBTU. Okay. So don't be confused on this unit. So MBTU, I'm not sure if it's mega, but M, no, MBTU is 1,000 and MM is 10 to the 6 naman. That's 1 million British thermal units, which is commonly used in natural gas. For quad, it's 10 to the 15 BTU, which is also used for energy in the global scale, no? In the national scale. Okay, so baka may ma-encounter kayo dyan as you go on doing your energy estimations. Okay, exajoule is 10 to the 18. Convert exajoule to quad. Okay, so 1 quad is equivalent to 1.055 exajoule. Okay, or about 1 exajoule. Ayan. So we also have what we call ton oil equivalent. Yan. So 10 gigaton oil equivalent. Kasi before, di ba, we were using oil, petroleum. No? So they're used to using this kind of units. But if you convert that to SI units, yeah, it is a conversion factor. So 10 gigaton oil equivalent is about 420 exajoule. 1 gigaton oil is 42 exajoule. 1 quad, 1 exajoule or 1.055. Okay, 1 megaton oil equivalent, 42 Pica ba 'to? P is for peta, sorry. 1 petajoule, 1 TOE is 42 gigajoule, 1 barrel oil. This is ton oil and this is and B is for barrel oil equivalent. Maybe every now and then you'll be encountering these units, no? Just for you to be familiar with. Ayan, equivalent to 6 gigajoule. 1 cubic meter of gas, particularly natural gas, is about 40 megajoule. Then 1 kilowatt is about 4 megajoule and 3.6. No? And then 1 BTU is about 1 kilojoule, about 1,055 joules. Okay? So 1 ton oil equivalent is also 1 gigacalorie. 10 gigacalorie. Then 1 ton oil equivalent is 7.33 barrel of oil equivalent. BOE naman. Ayan. So let's give an example. Solar energy, ayan, the estimated power can provide, no? Earth is about 1.8 times 10 to the 17 watts. Ano yan? Pag ganyang scale, yung 15 ay, ano yan? Peta, right? 15 is peta, right?
Yes po, sir.
So kung ito 1.8, so magiging ano siya, 00, additional 0. So petawatts, 180. Tama? Uh, Petawatts of solar energy we receive every year. Ganun kalaki. More than enough actually to supply the needs of the whole world, no? If we have the technology to convert solar energy efficiently. O pwedeng pwede. Solar energy pa lang, okay ka na. Okay? So earthquake is also very powerful. It's yan 2 petawatts. Okay? Now if you want to get the energy, you can just simply multiply it with the time, no? So, in 1 year ba it's ano, 3 32 seconds ba in 1 year? Can you compute? How many 32 million? Ba 32 million seconds in 1 year. You can check. Just multiply power and time, of course, to get the energy. And then it was global energy use, ayan, 1.4 times 10 to the 13. Ano yung times 10 to the 12? Anong prefix yung ginagamit natin doon?
Tera po. Ay, opo, tera.
Giga tapos tera. Ayan. So we have 14 terawatts, no? So 14 terawatts na need ng global, no, energy consumption way back in 2000. So again, solar energy is more than enough to supply global needs. Okay? Thunderstorm kinetic. So malaki din, no? If you can harvest. um, lightning. Space shuttle lift off, yung 747 airplane, ayan, may mga scales naman dyan. Sa supermarket, medyo maliit na siya. Energy per day, supermarket, that's, ano yan? 0.2 megawatt, malaki rin 0.2 megawatt. That's huge. For a supermarket per day. What else? Daily metabolism, mababa yan. Pag naipon yan, magiging fats na stored that excess energy into fats. And burning a light candle is just about 3 watts. Okay, orders of magnitude, exajoule, that's annual solar reflux, 5.5 million exajoule. 1 million exajoule fossil fuel, fossil occurrences are researched about 50,000 exajoule. We don't want to get them anymore because of global warming. What else? 440 exajoule world energy use. Again, annual solar energy is more than enough to power the world, no? Every day, every year. Again, if you have that technology, that would be the best, no? Efficient technology. And then the rest, ayan, New York City, 747. Ito, so there's an Ampere scale here. Small village in India. So if you want to compare, let's say yung sa regional, no, regions kasi siya eh. So you'll be, if you will express your estimation in terms of joules, no, instead of watts. Again, I'm not limiting you if you want to express your power energy potential into watts or joules, no? Kayo bahala doon. That will depend on the available literature, no? But of course, if you want to estimate annually, no? So that means you will be reporting that in watt hour, no? Or in let's say joules, no? Okay. So again, depends, no? If you want to report that in watts or in watt hour or in joules. I'll giving you the freedom to do that kasi it will depend on the literature that you will be using. But again, going back, the expected units, no, or scale that you will be probably be using, especially if you want to estimate the potential of the region, no, should fall under ano yan, PETA, no? PETA to exajoule, no? So dito you will see New York City annual energy falls between PETA and EXA. No? So ganun yung mangyayari when you do your estimation. So hopefully it will also reach that scale, no? Around PETA to EXA joule. But of course, if it's world consumption, that's already in the um, exajoule scale, no? Or terawatts. Okay? Pag mga small villages, no, sorry, terawatts. Terajoule, mas maliit pala to. Ano yung ginagamit natin sa world? 18 eh. 18. Sige lang. 80, this is 100, no? Penta? Hello, ayan. So, energy global. Ito pala. Okay. So, tama. That's terawatts. Pala. So, pang third, no? Global energy. Okay. So, yun. I would be expecting maybe around that scale when you do your energy estimation. Nasa nakatatlong slide. Another example. So, another example lang naman to. So, 1 candy bar is about 1 megajoule. Okay. 1 capacitor, 1 joule. These are just some examples. Ano bang interesting dito? US electrical consumption, 14 exajoules. It's much bigger, of course, compared to the Philippines. And then, a person, yan, in the US consumes about 90,000 kilowatt hour. No? This is, I think, in a year, no, per person. Ganyan ka affluent ang mga average person sa US. I don't know in the Philippines. It's a good study, if you let's say doing research in maybe energy management. No? That could be interesting. Especially now na monitor din tayo ng DOE when it comes to our energy consumption. They're also giving institutions star ratings, parang ganon, no? Parang energy efficiency rating. So yung mga government institutions are also being assessed, no, by DOE when it comes to energy efficiency. So maganda, may mga ganyan tayong studies din. Next, kayo as under energy engineering major, no, that could be a good study. Okay, so world energy consumption in 1 year, an average person uses about 18,000, no, kilowatt hour. Imagine US is 90. So ganun sila na greedy parang ganun. 90,000 compared to 18,000. So they are much they use so much energy, no, compared to an average person in the world, no? 90. It's ilan yan? How many times higher yan? About 4 times, no? Four and a half times
More than 4, sir.
higher than an average person.
More
Okay,
than 4,
human
sir.
heart is 1 watt. Yeah, more than 4. A human heart is 1 watt. Okay, konting electricity lang yan, titibok na yan. No? Light bulb, 100 watts. That's quite big, no? Ngayon, LED is just 9 watts, right? 9 watts, 7 watts. Malaki na siguro yung 15 watt na LED bulb. You can approximate horsepower into as equivalent to 1,000 watts. We know it's 746. A mobile, 100 kilowatts. Wind turbine can go as much as or as high as 5 megawatts. Malalaki na yung mga wind turbine ngayon. Okay, Boeing 747 is 250 megawatts. And a coal-fired power plant can produce 1 gigawatt of electricity. Or even bigger. It depends on the size of the power plant. And then world average power generation, 13.5. That's world. Okay, ito na-discuss natin to. Discuss this, yung efficiency, if you will remember a while ago. But the most efficient here is, of course, electric generator from mechanical to electrical. Usually falls around 90, no? 90 to 100%.
Sir Ferrer, may tanong po ako
Similar.
sa
Sige, sige,
do'n
sige.
sa previous slides, yung sa tao po, yung consumption ng tao sa American tsaka sa normal na
Ah,
ano pong ibig sabihin nitong
mm.
ano po, yung 90,000 kilowatt hour per person tsaka yung 18? Is it yung heat ng katawan niya or yung kinakain niya na kino-convert sa heat like calorie or joule, gano'n po ba 'yan or kasi may
So,
may
ano
may heat
yung
na
kung sa
lumalabas sa may heat din na lumalabas or carry ng tao like mga 80 to 100 for ano,
mm,
watts, 'di ba? Pero ano pong ibig sabihin nitong
mm.
is it yung kinakain
I
niya na
think
in terms of calorie or
no, I think this is in terms of the consumption ng mga appliances, yung
kasama na
mga
yung mga
gano'n.
lights, appliances, gano'n?
Oo, sa food, kaya pag bumili ka ng food, siyempre yung parang processing nung food na yon will consume that much energy.
Hmm,
So dun siya associated. Not
oo.
not about power body generation, hindi siya.
Hindi
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 siya
heat
sa
ng
body
body, hindi
generation.
siya heat ng
Oo,
body
hindi.
generator. Okey po.
Oo.
Baka kasama
So
diyan
more on
yung
the
kotse niya, yung mga ilaw, gano'n?
correct, correct.
Hmm,
Correct. Yung
okey.
kotse niya, pagkain niya, ano pa, mga appliances niya,
Appliance,
gadgets niya, et cetera.
gadgets,
Oo.
cellphone, gano'n.
So
Opo,
pertaining dun sa correct.
consumption
Pertaining
niya.
dun sa consumption niya mismo.
Hmm.
Yun yung tinutukoy dito. Although ano bang pelikula yun, yung ginagamit yung katawan ng tao as battery? I think that's Matrix, no? So if you watch Matrix, they're using human bodies as battery to power yung mga robots,
Robots, kasi
mga
yung heat may
AI.
ano rin sir,
Oo,
may yung heat kasi 'di ba ay yung katawan natin may ano rin
they
charges,
harvest
'di
the
ba?
heat.
May charges, may heat.
Yeah. So they harvest that heat. Yun yung concept ng ng Matrix, if I remember. So they have to keep the people alive, brain alive, but parang body dead, parang ganun. So that they keep on producing body heat that is used by the robots to power themselves. Nagagawa sila ng parang imaginary world, no, virtual world to keep the mind alive so that the robots will survive. So ganun yung concept ng sa sa Matrix. She's actually cool, no? It's possible, I guess. Okay, but for this, yun nga, it's more on the affluency of a person in the US compared to the average person in the world. Kasi they have much more, parang resources eh. They can buy a lot of things, no? They can use a lot of devices, no? Equipment. So the energy associated to those activities is much higher, no, compared to an average person. Much more siguro kung nakatira ka sa probinsya, then much, much less. But if you're in the cities, obviously, have much more energy consumption compared to the rural areas. Okay. Yeah. So again, here you can see that electric generator has the highest efficiency from mechanical to electrical. So battery, how about battery? Storage battery is about 70%. Yan. Mataas din ang battery, kaya lang mabilis din ma-drain ang battery. It depends on the appliance being powered. One of the lowest is incandescent kasi majority of the electricity used is converted to heat, to heat loss. Okay, automobile engine between 20 to 30, I think this has increased already, no? Can have engine as much as 40%. Yeah, diesel engine between 30 to 40. In power plant, 40%. Yeah, and so on. Okay, and then there's this different conversion, no, either from chemical to thermal, electrical to mechanical, mechanical to electrical, and so on. Okay, so that's energy conversion devices, personal efficiencies. Okay, another comparison. Ito. Okay. If you will use wood and wood-derived fuels, the conversion efficiency of the technology associated to the utilization of wood typically falls around 20%. 20% lang yung mga boiler. Coal can yan 31% or higher depending on the quality of the coal. Diba? So may mga lignite, may mga different types of coal. Nuclear is 33%, petroleum 35%, hydroelectric, the conventional hydroelectric, probably this is a smaller version, only 35%. Wind 37%, it can go as high as 40. Natural gas, ayan. That's why even if natural gas is a fossil fuel, we're still promoting the use of natural gas because it's also one of the more efficient um, way of generating electricity using natural gas. So 45%. Okay, and then there's some information here, energy consumption generated in ICT. Ayan, another comparison. Again, another table showing, again, generators, electric generators is the most efficient. That's why EV is also being promoted in the Philippines kasi it's also efficient, no? Don't need an internal combustion engine to run, no? You just need batteries and electric motor. It's very responsive. Kasi nakapag-drive na rin ako before ng EV, very quiet and very responsive. Okay, yung mga modern EVs nga may sound pa. May mga yung mga tawag diyan, mga parang racing design na EVs. May mga sound system na parang kala mo merong internal combustion engine. Okay, they're one of the more efficient, highly efficient. Battery also 89%. This is a little bit old data na. Solar cell ngayon commercially available between 20 to 30%. Commercial photovoltaic cells. No? So for thermal, you can see here there are highly efficient thermal energy and then less efficient. Yeah. Water heater, for example, which uses electrical, has high efficiency compared to a gas stove. Only around 24 to 30%. Okay, kasi may mga ano yan eh. May mga heating capacity pa yung mga materials. Okay, so again, this is just an example. Take this into account. Ayan. Kapag kayo nag-estimate 'di ba, may guesstimate na kayo halimbawa biomass energy. So there's an associated technology for your biomass energy estimation. And then you have to identify the technology. So make sure to also include the efficiency of that technology to make your estimation more realistic. No? So siguro ito yung that's why I'm emphasizing on the efficiency. So when you do the estimate, make sure to include efficiency. Don't assume that it's 100% efficient. Okay? Anyway, we will go through that in the succeeding lecture regarding efficiency. So make sure when you identify that tech, include the efficiency in your calculation. So don't forget that. Okay? Okay, sample exercise. Tapos na siguro to? Diba? Almost one na. A consumer uses 6 kilowatt immersion heater, a 4 kilowatt electric stove, these are all electric, and 300-watt lamps for 10 hours. So how many kilowatt of electrical energy have been converted, and how much does that consumer need to pay? Yun nga, estimate nila. So may kilowatt, may 100 watt.
886.
800,
86.83 po.
so 800 pesos, ano? Ayan, 6.4, lang natin. Tapos, divided by 100, 1,000. Will run in 10 hours. Ayan. So, ano babayaran? 886. Tama, no? So, ganun lang siya kasimple. Although, sa Meralco, may mga china-charge pa sa atin kung ano-ano no? Sa tubig nga, ganun din May mga environmental fees, ganung klaseng mga charges. Tapos yung mga generation fees, mga losses, china-charge din sa consumers. So, lalo mahal ang bill. Okay? So, ito, last na ata to. Ano to? Another example. Ayun pa pala. A man doing no or very little physical work needs about 2,000 kilocalories of energy in his daily food. The body converts this energy almost entirely into heat. So, pinapakompute lang yung watts. So, conversion lang siya. 2,000 kilowatts. Ayan. Tapos, 2,000 kilowatts. Kilocalories. No? 2,000 kilocalories per day. So, minultiply natin siya into joules. No? Yung conversion na 4.186 if you remember. 4.186 joule per calorie. But since this is in kilocalories, so you have 4.2 to 186 kasi ano na siya, ni-round up na to 4.2. Okay, so you'll get 8.4 megajoules. To get that into, or to convert that into power in a year, 86,600. This is total time, no, in a year. Tama ba? Can you compute? Tama, no? You have 86,600 seconds in a year. Kailangan nyo rito sa estimation nyo Pag mag-yearly, kayo? Yearly, estimation. Tama? So, 24 hours times 60 times 60. Oo, tama. 86. So, that's yearly. Okay? So, in a year, our body can produce, if you're consuming 2,000 kilocalories a day, your body can generate 100 watts of heat, body heat in a year. Okay. So yan yung kinokolekta sa ano, no? Everyday. Kung everyday yan, 8.4 divided by, ano yung ilang seconds in a day?
1,600,
3,600. Hindi divide,
86,400, sir.
86,400. In a year yon.
Day
In
lang
a
yun, sir.
day. Day lang ba to? So per day lang pala to. Tama ba? Okay. So ito pala yon. O yan. Imagine, kung sa, ano yan, kung sa matrix yan, isang tao, pero syempre papakainin mo yung tao para makapag-produce siya ng, ini-inject yun sa matrix yan. So makakaproduce siya ng 100 watts of, if you are able to convert that body heat into power, ano, kaya mag-produce ng 100 watts. Imagine doon sa matrix kung napanood nyo, isang tower ng puro tao. So kaya nga, ang ganda ng concept ng pelikula yan. Gawin mong battery yung tao. But you have to feed. No? So, to keep them alive. Tama, 86 nga pala isang araw lang pala. 84 times 60 times 6. Oo nga. So that's in a day, it's 6,400. In a day, times, 365 and 1/4. Tama nga yung, it's just in a day. Okay. 31 million pala in a year. Sige. Okay, last na pala yan. So, dito lang muna tayo. I will continue my lecture next meeting on ano na tayo. Punta na tayo sa biomass. At tayo sa biomass estimation. Para masimulan nyo na, no, na mag-gather ng data and literature for your energy estimation. Again, the parang mandatory, no, or required renewable energy is biomass plus identify uh, which type of renewable energy is suited for your selected region. Okay? So yun yung parang objective for EG 513. For HP 513, sa ano tayo, nahanap muna kayo ng ano nyo. Hopefully nakahanap. Sino dito yung sa HP 513? Dito ba? Yun nga, can raise your hand. Meron ba dito sa HP 513? Marami dito eh. Ayan. Oh. So, I hope nakaharap na kayo ng papers. Please post their paper to present. O identify na lang kung anong topic yung nakuha ninyo. 'Di ba if we go back, ilan ba yan? One student ba per topic? Ilan ba kayo sa klase sa HP? HP. Ito yan eh.
130 yata eh.
3 members pala.
130.
3 members? Hindi, review paper pala to. Yung sa report, ano ba sinabi diyan? Ilan ba kayo in total? So yun no, may maximum tayo na um, student per topic. So kung for example ano ba yan? Ayan, sa gaseous fuels, may limit yung number of students na magpe-present na research papers related to combustion of gaseous fuels. Sa liquid, ganun din. Sa solid, ganun din. So first come, first serve yun. So, yun, send your paper for review and approval as soon as possible. So you can start preparing your presentation. Okay? So, HP 513. Ilan ba lahat yan nandiyan? Teka lang. Saan na yung ating listahan? Saan tayong listahan? Energy fundamentals. Ay, wala yung aking ano, ay yung aking list. Ilan ba kayo lahat? Sabi sa year-end. Na-mention ko ba yan last time? Kung ilan yung per ano? Ilang student per topic? Diba? Ano lang last list. Okay. So pag-iisa lang talaga. Wala palang repetition. No? So no repeating topic. So one for gas, one for solid, and one for liquid fuel combustion. So definitely there will be no duplication. But again, first come, first serve. First to secure the topic, no, that will be reserved for that student. Okay? Okay. So are there still questions, verifications? No more? Okay, so with that, I'll see you next meeting. So please start doing the class requirements. Could finish early. Okay, sige. Thank you. Happy weekend.
Thank you,
Thank
sir.
you, sir.
Thank you, sir.
Thank you po.
Oh,
Okay.
sir. Thank you. Salamat.
Thank you
Thank
po.
you po.
Oh, sige.